Welcome. I believe, no, we're not live yet. Okay, now we are live. Now we're live. All right. Hello, friends. Okay, just kidding. We are live now. How's everyone doing? Hey, Shubham. Very excited. Thank you for making it. How's everything going, Nina? It's going good. It's going pretty good. It's going pretty good. Today we're doing a Friday lunch and learn instead of a Saturday one, but I'm very, very excited for today's guest. How are you all doing? Hey, Michelle. Iris, never missed one, huh? You have a streak going on. So we're gonna see. I know today is a weekday, so probably not as many people would be able to catch it while it's live, but that's totally fine because everything will be recorded and it'll still be there, so don't worry. Do not worry. Everything that Mickey's gonna say will be there. Hello, everyone. Hey, Sebi, it has been a while. Hello. Um, yeah, I'm so excited for today's talk. So I'm so happy that Mickey agreed to give this MLOps talk. MLOps has been blowing up. I think it has been, right, Mickey, for like, say like a year or so now. Like there's or like a couple years. It's just like I feel like it was kind of like data engineering. Like everybody was like, oh, like what's that? And then suddenly it became really, really popular.
Yeah, I mean it's been a few years in the making. It's interesting because like with all the LLM stuff coming out, like you kind of realize sometimes living in the Bay Area how much of an echo chamber it is because it's like almost recently where people have started saying like, oh, it's like there's this thing, there's MLOps and there was LLM ops, and now people are like, oh my god, is like LLM ops like fading out? It's like it's only been 6 months. Like what's wrong with people here? So yeah, but I think like yeah, it's been growing over the past few years just because like ML is everywhere. Like you can't get away from it. It's definitely having an awareness or intuition about how machine learning products work is like so important, and it's definitely important for people who want to like grow their careers in tech for sure.
Oh yeah, 100%. I've just been hearing about it. Like even in Austin, there was like an ML Ops meetup activity. I don't know. I also saw on Insta a lot that there's a lot of ML Ops events and things that you go to, which is really cool. Shall we
Yeah.
get started? I know you have so many things, and I'm so excited to learn as well.
Yeah, totally.
Do you want to give an intro about yourself, or shall I? I think you'll be good.
Yeah, I can go ahead. And then you can chime in and let people know like how awful I am and how messy my apartment is since you've been over so many times now.
It is
So
not.
yeah, so hello everyone. Tina's crew. Y'all's probably do know me just because like one, Tina and I are friends. So like I have popped up a few times here and there. Uh you've probably seen me at some of the meetups and gatherings like in Austin and Salt Lake City. Unfortunately, I will probably not be attending the next one because I'll be in India in February. So, just so
India
sad.
crew. She's gonna be
Yep.
there.
Yep. I'm gonna be there. I'm gonna be visiting. I'm gonna be in Bangalore for 3 weeks, minus however much time I am taking in the sites. So yeah. But more about me and who am I to even be speaking about ML ops in this 101 crash course today. Um, so I was born and raised in SF. First off, I've been here for most of my life. I went away to college for 5 years, super seniored it over at UC San Diego. Went there for biomedical engineering pre-med. Basically, more or less, almost failed out my first year, so I had to quickly pivot majors to anthropology and economics. So
Just like
graduated
me.
with
Sorry,
a
just want that.
with an amazing 2.6. Well, yeah, right. Like it's like pivot. Um, yeah. So did that. Graduated UCSD in 2013. Oh my God, it's been years. Um, and then just gradually worked my way through tech. So first couple of years I spent working kind of as like an analyst. Then I pivoted to working as a data scientist for companies like Autodesk and Teladoc, and then pivoted once again to doing MLOps. And a lot of these pivots were like self-taught, informally taught pivots. So because my GPA was just so terrible in my undergrad, I ended up doing a lot of like alternative education. So boot camps, taking classes at the local community college, self-studying, doing MOOCs off of like Coursera and edX, all that good stuff, right? So did that. Now I'm head of we say I developer relations, but head of developer relations for a company called Labelbox. So a lot of what I do is literally this. It's like taking all the all the painful bad experiences and hard learnings that I did, and then helping people not make the same mistakes. But also, there's just generally a lot of noise, like in the ML and data science space. Like, it's very exciting, but also, I think if you're, if you're trying to build a career and you're like, okay, what tool do I like learn or pick up, or maybe you're working in a company, you're a junior or fresher, and you're like, how do you get promoted and all that? Like, it's super confusing. So, that's what I love doing. I love talking about how we can build ML products, how we can do it, not just better, but in a way that's more, it's in a way that is less painful. And then doing a lot of education there. So, and it's still a lot of building, still a lot of building. So that's kind of my background. What else? Yeah, that's the most important stuff. So once again, really glad to be here with y'all's. Uh, especially with all the other renegades here and degens. So okay, so things we're gonna talk about. So I've told Tina like she can feel free to interrupt me whenever, and if y'all have questions, just like drop them. This is super informal.
Yep. Just
So
ask any questions and
yeah,
I will be moderating the chat.
yeah, totally. And I think the things that we had talked about, like Tina and I, about what could be kind of valuable for y'all's, right? Is first off, like let's kind of define what MLOps is. Like I get a lot of questions about people going, "Hey, like we want to break into MLOps." But to kind of and then they'll quickly follow up with like, "Oh, should we pick up GCP, Azure, Databricks, like Kubernetes, yada yada yada." So those aren't bad questions, but it's better to kind of start with like a foundation about like what MLOps is actually like. What's the difference between a data scientist versus an MLOps engineer, for example, right? So it's good to kind of understand, have that foundation, because then that kind of helps you ask better questions and it helps you kind of plan stuff out a little bit more seamlessly. We're going to talk about like what does an ML platform even look like? What does it look like? You see all these different system diagrams, but like what are the core components to understand? And then even, for example, I don't know how many people know about this, but there is this VC named Matt Turk. He publishes what's considered one of the more comprehensive maps of like the tool ecosystem. And then like how do you interpret it? How do you apply what you see there? Because he's got like 200 million tools on that thing. So like which ones do you actually need to pick up, right? We're going to see what we can cover today, but whatever we don't cover, first off, you can hit us up like both on social media, right? Wow, I am also running out of battery. Haha. That is hilarious. Let me just plug that in real quick. Okay,
Can't even
fantastic.
tell. Can't even tell. There was a question while you're
Yeah.
taking your battery. Some from Bharat. What is the difference between an ML ops engineer and an ML engineer?
Yeah, that's a great question. So let me actually dig into a lot of slides. So, but I think it's worth talking about this. Okay. Let me go forward. So the short answer is it's the scope of what you work on, and it's also like okay, so a better way to frame this actually is so when candidates come through, right? When they interview for a role, So I was on the hiring committee for global engineering over at MailChimp, which is really surprising they even let me on that thing. Just because like I'm not like the most amazing engineer out there or even in that company. The key question to ask if you're, for example, considering to pivot, like pivoting into MLOps, right? Or if you're trying to figure out whether you should become an ML engineer, is which is more important to you? That you train and develop and deploy your own models? Like, let's say, for example, in a year, which is more important? You train, deploy, let's say 2 to 3 of your own models, or you help other people train, deploy 10 models that you don't own, right? That's the question we always ask people who come in through the door. Because what MLOps is you're defining the tools, abstractions, and processes to help other people do ML faster and better, right? Now, as an ML engineer, you can think of an ML engineer as like a full stack data scientist. This was a term that was like super popular like about 5 to 10 years ago. And the idea is that like as a full stack like data scientist, right? Like let's go actually. So once again, we'll send these slides out later. Let's go back to let's go to what that actually looks like, right? So as a data scientist, you'll go through this process of like, you get a bunch of data in tables. You'll like analyze it, you'll, clean it up, you'll put it in a Jupyter notebook. You might share it as a dashboard. So that's what we call on this journey. Let me pull it up. Screw it, it's not there. Okay. So there's a framework called the 4Ps. It is, it's descriptive, predictive, something, and then prescriptive. It's this idea that you are exploring the history, like what happened, like using data. Understanding what happened, you then say, okay, like what conclusions can I draw from the data? How do I predict the future? And then based off of that prediction, what actions can I tell someone to take based off of it? Right. So as a data scientist, like any project you work on is probably going to encapsulate that journey. You're given that data, you analyze it, you train a model off of it. Maybe you do like a Streamlit demo or a Streamlit application to share it. And then you might go ahead and deploy it. A lot of data scientists don't like deploy their models. They might work with an MLE or with an MLOps engineer to do that. But with a full stack data scientist / an MLE, you would be able to like say push to production using your internal company's tooling. The MLOps engineer is responsible for developing that platform and tooling. So that's the way you can kind of think about it. Full stack data scientists or MLEs, they are consumers of an MLOps platform. And the MLOps engineers are the builders of that platform. But
That's a really good analogy.
yeah.
Like not analogy, but description of that. That makes a lot of sense. Someone has a question. Do you need a master's in AI to do MLE?
The short answer is no. So functionally, in terms of like how to actually, like what you actually need to build it. Okay, so the beautiful thing about tech is like any skill can be like learned, right? So for example, 2 awesome resources I really enjoy. Let me go ahead and stop sharing that I think are really useful, especially if someone is like considering to go into the field. Is first off, let me go ahead and reshare this. Great. So first off, I would highly recommend for folks who are interested in MLOps, there is this GitHub repo called Awesome MLOps. You can check it. It's by forgot what her name is. Visenger.
Messenger.
Yeah, that I forgot if that's her name or if that's her handle. I think it's her last name. So she has this repo that is great, and it's got all these different resources. It can be a little bit challenging to read through. She also has a site called MLOps.org. And then let me go ahead and also share that as well. Share screen. That is not it. That is Data Robot. Hold on. Let me also... MLOps. Okay, let's just Google this real quick. No, this is bad.
Don't worry. We can also provide the resource later.
Yeah.
Yeah, we can do that. Don't worry. So
Yeah.
yeah, for anybody who wants, we send out weekly future event notifications, also summaries and resources, including the slide deck for this live stream. So it's like one email including next week's live stream and then what was the past live stream. So the link is in the pinned post. So if you just put your email in there, you can get all these different slides and stuff. We'll send that over. Do not to worry.
Yep.
So kind of adding on to that as well. So Amit, I'm gonna say your question a little bit later because Ibrahim, your question is kind of building off this one, which is do you work mainly on automating and slash or scaling the machine learning pipelines? So kind of you were saying about the consumer versus building it. So from an engineering perspective, you're building it and then you're automating it and scaling the pipeline itself. Like how does that interact with other people, like data scientists, for example?
Yeah,
Sorry, let me say that a
absolutely.
question again.
No,
Do
no.
you
Yeah,
mainly work? Okay, okay.
yeah, I get what you're saying. So
Mhm.
I think it's helpful to talk about what an ML platform looks like. So let me do that. Okay, so first off, let me just kind of show you this diagram, right? So any like ML ops or ML platform diagram you see out there, you can essentially generalize to this, right? Which is essentially two dimensions. It is what stage of the ML lifecycle is kind of corresponding to that. And then it's also like how low level to high level the tooling is, right? So for example, examples of tools that like fall into this. These are some tools and like how they map to like one of the squares, right? So for example, most people, the reason why you would use like GCP or Azure or AWS is you're going to essentially use them for some kind of compute and storage, and maybe you'll use them for like some monitoring, orchestration tools, etc., etc. You have other like open source options that will, for example, MLflow, weights and biases. Everyone uses it for experiment tracking. MLflow, you can use it for experiment tracking. You can use it as a mol registry. You have some tools like YLabs, evidently, that are used for monitoring evaluation. Comet, Snowflake, Redis, things like that, right? So that's what a lot of platforms look like. Now, what are they actually like trying to do? And this is where it's kind of useful to take a look at that, at this sort of like breakdown. So in general, your entire like goal as an MLOps engineer is help make data science faster. Make it faster, make it easier, all that good stuff. Right? So there's a number of ways you could do that. And as like an MLOps engineer, you have a number of different like places where you interact with data scientists, right? So if we take a look at what does the ML development lifecycle actually look like? So during, for example, your like data set preparation, as like an MLOps engineer, for example, you might decide, okay, what we need to do is we need to make sure data scientists aren't just doing Jupyter spaghetti code, We need to make sure they're like, when they build their models, they're doing it in the same environment, both in development, that also mirrors the requirements for production. So, for example, they have the same libraries available, same version of scikit-learn, same version of Spacey, all that good stuff, right? So you might decide as an MLOps engineer, like, okay, well, what we're going to do is we're going to do like a cloud-based development environment. There might be a container that backs it. So that essentially when the data scientist is done, they have their code review. You can then kind of push it to some kind of like staging environment where like you'll have a bunch of tests that are run, you'll have mocks, things like that before it gets pushed to production. Another place where MLOps engineers will typically like interact with data scientists and also data engineers too is like when you have feature pipelines. So let's say, for example, you're doing like a forecasting model. Forecasting models are typically a little bit easier. So maybe you're just trying to make sure that like, okay, the query that is used to create the machine learning feature doesn't like totally blow your like compute requirements, right? Maybe you're also taking a look at what do we do if like we have a null value that comes in. So that's one place where like an MLOps engineer might come in is when they're doing stuff that's like ops work. Things that you kind of need like an eyeball to take a look at and to really kind of understand like, okay, like how do we fix this? The other place where like you'll see an MLOps engineer interact with a data scientist is like, okay, so you go through all this, you train your model. You're probably, most people will do some kind of batch training in prediction because that's just a lot of times the easiest to get started with. Most people aren't doing super sophisticated continual training and learning in prediction. So you have a model and let's say, for example, it's got all the tests running, all that great stuff. You might want to A/B test your model before it even like gets pushed out to production, right? So that's another place where an MLOps engineer and also data engineers work together and where they kind of interact with data scientists.
Makes sense. Makes sense. There's some follow-up questions to this as well. So, and this is awesome, guys. Keep putting the questions there, and Miki is amazing at just being able to meet people where they are and explaining. So okay, there was that question a little bit earlier, which I'm trying to find right now. Okay, so can you please share how the ideal ML ops maturity journey slash stages look like for enterprises? I think you can go into that a little bit. You have some of that a little bit later, right? Like going through the stack. Um, if I'm not mistaken.
Yeah, I do. But what I can also do, let me just touch on that real quick. So a lot of times, okay, so let's actually just talk about kind of like where did the MLOps term even come from? And then that'll help you understand why a lot of times you see these system diagrams that just look like an absolute mess, like just an absolute hot mess. So if you want to look at like the origin of like MLOps as a category, it's kind of like data science, right? Like statisticians will say, yo, we've been doing data science since like many hundreds of years ago in some way, shape, or form. Same with MLOps. It's not like when someone coins a term or they name a category, it's not like it suddenly was birthed into existence. It just means someone got there first and then provide like the strongest argument and collection of thoughts around like what that category is or like what pain point that category is trying to solve, right? So for most people, they would argue within the MLOps world, they would argue that that inflection point was 2014, specifically with some papers that were published by Google, and and these are pretty impactful because the first one is like that's where you see that same diagram show up everywhere. The actual paper is worth reading. The high interest credit card of technical debt machine learning. It was a recognition that doing ML in production is like really hard. Like 90% of your code in a machine learning system or project is not actually the ML code. Because you could probably write like a train.py file. You could do like maybe a feature engineering.py file. Like that'll be like really, really long. But in terms of pure lines of code to actually like train and deploy a model, it can be like 10 lines. Easy. 5 if you like skip all the type hints and like all the try exceptions and all that. So most of the like nonsense is, or most of the code is coming from everything that is needed to support that like pipeline, right? 2017 was another paper, was like the test score. That's also a really important one. And if you're, for example, someone who comes from more of a SWE background and you're trying to go into ML, it's also worth looking at this paper because, for example, on the left is you have like your normal set of development suites for testing. On the right is all the things you have to consider when you're doing even a really simple like forecasting model. So, okay, now how does that tie into the like maturity journey, right? Of like a startup to an enterprise? It's important to recognize that most of the companies that define the early days of MLOps were the big guys. Facebook, Amazon, Google, Twitter, you name it. Uber, they were all companies that had a ton of data. They had to solve all these problems when you couldn't just buy the product from like Google, you couldn't just buy it from AWS, you couldn't buy it from Azure, right? So all these tech companies had to solve those problems internally. So and not only did they have to solve these problems internally, but they maybe have been around for like 10 years. 10, yeah, 5 to 10 years. So they already have what's considered like a quote unquote legacy stack, right? You can't just kind of buy a new tool and then like swap it in and then like get rid of it every time. So their stuff ends up looking a lot like this. Like on the left is Google's sort of like imagined MLOps stack right there, kind of like what they, what they think you need. If you're like a really, really mature setup. And then on the right is all the different jobs that this translates to. So, like, for example, like Tina, you probably saw this over at Facebook. Like every single person is doing a very specific thing. They're interacting with like a very specific part of the internal tooling. And you have like 20 million jobs, like supporting a single like product or feature. You might not always see them, but they exist. Now, if you're a startup or even like if you're a solopreneur building your own product, you don't need this. Most of this you really don't need it. And in fact, like with the LLM world, right? The new pattern. So there's this guy Swix. His name's actually Sean, but he goes by Swix, right? So he wrote this really good blog post called "The Rise of the AI Engineer." And so this is kind of what he talked about is like the new flow of how people build ML products. It used to be that you first had to have the data set, and the data needed to be clean and needed to be in a certain format. Only once you had that could you then build a model. Like, let's say, for example, a classification model or a recommendation. You name it. And then only from there could you now create a product that you could then send to users. And what he was arguing in the Rise of the AI Engineer blog post was this entire pattern of development has been totally flipped. Because now essentially you have these like super powerful models, whether it's LLMs, whether it's computer vision, whether it's multimodal, that are now available just behind an API. And even with OpenAI, DevDave, they released a ton of stuff about agents. And you could first like actually build a prototype and send it out. You can see if people like it. From there, once you kind of have identified, okay, like there's real demand for the product, now you can start thinking about how do you scale your data? How do you make it cleaner? How do you augment with like other data sources? Maybe you have like private data that you want to access or that your users want to like do something on their own private data. After that, then you can say, okay, well, now we've identified that this product is actually, there's a good fit. And then let's say, for example, you want to add additional features. So you create an app where someone is like, every time I make a purchase, I want to know in the future how this is going to contribute to my net worth. Let's say you want to do that. Now, you might create an LM interface to like take your question, turn it into some kind of embedding that then pulls from a database of, let's say, for example, reports on personal finance to supplement like with additional statistics, maybe additional model weights. But behind it, you want actually a forecasting model that is presented as part of that response that pulls from your like bank history and account. So you might actually just use like a simple forecasting model to then kind of supplement that like that holistic picture of your net worth. So then you'd go on and you would then like train that model. Or you would like use an existing something out of like scikit-learn or what have you. So that's kind of what he's saying is like this is like the new way of like doing ML products. So in terms of like the maturity journey, there is one, but it doesn't need to be the same for everyone, right? Especially if you yourself are like trying to build products for as a solopreneur, or if you're trying to build products for like a small team.
See some other questions here. Question from Sebi. Does MLOps include data ops as well, as you get to work on MLOps alone or on an industrial requirement perspective? I think there's a lot of questions here that has to do with kind of where does the scope of MLOps end? Because it seems like
Yeah.
there's like a lot of, it's almost like you're kind of building a lot of things that encompass a lot of things and a lot of different cross-functional partners as well.
Yeah, totally. So it really kind of depends on, so the answer is always like it depends, right? Um so for example, let's go to, let's talk about, just land here, right? And I mean, this is like a conversation that like Joe and I, Joe Reese, for folks, author of the Fundamentals of Data Engineering book. So he and I, we've kind of gone back and forth on this a few times, where the area that does get a little bit like tricky to like draw firm boundaries around is like the data set and the data ops part. That's a little bit tricky because so where do you actually need data coming in for like an ML like product? There's two places. The first off is for the training, and the second part is for prediction. Right. So data engineers are they're largely responsible for delivering data and for building the architecture for data sets, usually for the entire company. Although in a lot of cases, the reason why you see a data engineering team set up is because they're trying to support ML, right? So machine learning features, that's a little bit of a weird part in terms of like who should support that. And I can give you two arguments, the for and against. So what's the argument for having data engineers owning the featurization process? Well, the first off is that a lot of times data engineers, they actually have more experiences and a skill set in terms of developing performant code. Many of them start off as engineers. A lot more of them start off as engineers than, let's say, for example, data scientists, which granted, most data scientists come from like a mixed bag background anyway. You have some people that come from SWE, some people that come from business. I know I came from the business side. So a lot of times data engineers, they have the skill set to actually write performing code that will scale, right? The reason why you actually wouldn't maybe want a data engineer owning that process and why you would want them to be more like informed or consulted with the data scientists or the MLOps engineering process. So first off, like machine learning features are a little bit different from like analytics data sets. So in an analytics data set that feeds like a Tableau dashboard for like, let's say marketing or finance, you expect every feature to actually have a very clear logical representation in like the domain. So for example, you would expect to have a feature that's like revenue. You'd expect to have a feature that's like net worth. Like these are named, well understood columns. That's not really how like machine learning products work. Sometimes to get the most performant machine learning model, you actually have to create like nonsense features. Like you can think of an embedding as a nonsense feature in a way. And by nonsense I don't mean it's not important, but a lot of times it's like this numeric vector representation in latent space that may or may not correspond or be able to be ordered in a way, right? So with machine learning products, it's like it kind of doesn't matter how much sense the feature makes. Sometimes you just create features that like don't actually have that like logical business representation, right? So that's something that like where one it might not be useful for a data engineer to be a part of that process, but the other part to actually think of the other argument for why it might not make sense for a data engineer to own the featurization process is when you're looking at evaluating features and how they contribute to a prediction. For example, data drift is a really, really big issue. And what's data drift? Or even what's the impact of data drift? So with data drift, or actually data set leakage is the really hard one, right? With data set leakage, you essentially have information that will not be available to the model in production, such that when you train and evaluate the model like offline, it performs really well. And then you put it into production and it does poorly. So either it didn't have either that feature is not available or the information that you're giving the model is not actually present at that time. Right? So there are these kind of issues around statistical knowledge and practice that a lot of data scientists do have because many do come from academia. Many of them have done research. So they're very aware about the influence of feature engineering, of data processing, of model evaluation, and how that will impact the model because they have that domain experience. So I've seen it go both ways, where data engineers they own the featurization after the data scientist has already defined the business logic and they've already created the model offline. So the data engineer just needs to like mimic and optimize the featurization like in production. I've also seen it where data engineers are kind of like treated as like de facto MLOps engineers. So they kind of have to like a lot of times they're taking on that like the MLOps serve role and responsibilities to kind of make sure the model gets out the door, right? So I think in terms of like career though, like I do think sometimes I mean at the end of the day you kind of have to like ask yourself like are you an engineer, are you a data scientist, or are you like an MLOps engineer data engineer? I think in terms of like career proofing, even though I focus mainly on MLOps engineering, I do try to keep an eye on like the data engineering world. Because at the end of the day, like you don't want to turn down a good job because it's not in your lane, right?
Awesome. I think that was really helpful in kind of clarifying that. And that answers like several of the questions that are here now. Let's see. I'm trying to group these questions together. Oh, and then from Diego as well. I think this really echoes Mickey's point. Working on a startup and my job as an MLOps engineer includes data engineering task as well.
Yeah.
It says, okay, there's a really great question here. If it would be great if you get time to double click on MLOps components, specifically monitoring and logging, offline metrics, data/feature drift, online metrics.
Yeah, totally. So I'm trying to think about what's a good way to talk about that in a way that's not going to lose people.
It is getting more specific.
It is getting way more specific. Yeah, actually, Diego, if you could add some more color in terms of like,
Amit. Yeah.
oh, is Amit? Yeah,
Yeah,
if
Amit.
Amit could add a little bit more color in terms of what specifically in those areas. So, okay, maybe I could approach it from this perspective. In terms of like your monitoring logging choices, I think, and this kind of ties into the maturity question about like depending on like what size of company or what size of team you're on, like what tooling choice should you use? And like my 2 cents is you probably need a lot less tooling than you think you do. Like even though I work for like an MLOps vendor and I know I'm supposed to like sell you stuff, like it, not here on this call, but like, in general, right? I would say like a lot of teams would benefit from being very principled about knowing what problem they're solving, right? Okay. So, for example, what does it look? Okay. So you have all these tools. You have this kind of idea of what an MLOps platform can look like, right? So let's talk about these tools. So I kind of did stick them on like a single square, but like a lot of these tools like out here, they're actually expanding, right? They're expanding either up and down. They're expanding up and down, left and right along the ML lifecycle. Um, some of them have everything, right? The major cloud vendors like have everything. Now what would you actually need to get started like as a solo data scientist, right? So I call it the Duke Nukem approach, where you just kind of need literally the bare minimum. Like, for example, in terms of like tracking logs, let's say you're just tracking logs about whether or not your like application's working. The simplest approach would be to like use something like you could use like the logging Python method and essentially have some kind of like GitHub action where I don't know, like anytime there's like an error, you just log it. There's also like the quote unquote elk stack is like really super popular, Elasticsearch. Um, you could also use that. So, or you could just like you could either write directly to like a text file in like an S3 or GCP bucket, or you could like write it to a database, you name it. Like your initial like logging and monitoring doesn't need to be super sophisticated, right? As you get like into a bigger team, it is going to become a lot more sophisticated. Like you might use a monitoring evaluation logging tool that is like ML specific as opposed to like as opposed to application specific, right? And logging models too. A lot of folks also use MLflow. Like they'll use a combination of MLflow and some other kind of like logging. The like ylogs is an open source tool. There's a few others there, but it can be really really simple, honestly. And that's also the benefit too of having some kind of like deployment rollout system. Like when you're in like the really smart thing to do if you're like on a data science team and you're putting models into production is you do what's called shadow testing where you don't actually put the model in production. You just like have the application run. What you do is as like new data comes in, you like run the model offline and then you see like what would the model have like said or predicted versus like what actually happened. Right. And that's like a really good thoughtful approach instead of just YOLOing it and just pushing the model out. Like a lot of people are like, "Oh, you can test in prod." It's like yeah, you can, but if you're a startup, you're going to have to do things a little bit hacky. That's
Mm-hmm.
totally fine, right? Because the name of the game of the startup is like you just need to like get money through the door and you just need to like survive for your first like year or two. And then from there, you can think about scaling. Like a really popular project in the LM world, for example, was Room GPT. Was created by Hassan, who's the DevRel over at Vercel. It was in one of the early viral like Gen AI projects that went mad on TikTok and Twitter. And initially, like he just kind of he built this MVP product using Vercel, and I think Tailwind, something else. I think he bought like minimum GPUs and like compute for it. And eventually he had to kind of like keep racking up the compute. He was doing like I think some logging just to see like how people are using it, but he wasn't doing anything really more sophisticated than that, right? So you can scale up your logging and monitoring as like your actual product uses scales because if for example no one's using your product then it doesn't really matter. You don't need logging and monitoring beyond like the typical stuff, right? But once you do have like heavy usage and you want to understand, for example, are there certain user segments where the predictions are like not as valuable, then that's where it becomes a little bit more important.
So there are quite some follow-ups to this question as well. So we're going like deeper into things, which is really cool. And also, Mickey, I'm just gonna say, like these diagrams, did you actually make these diagrams yourself? Did you generate them using some
I
sort of tool?
I did the rough ones in Excalidraw, and then when I was at so these were generated when I was at Feature Form. Our designer made them look way better in terms of like yeah. So for example, this is what the original diagrams looked like. It was hand drawn, well, like on Excalidraw, all that good stuff. And then I worked with our designers to actually make it look grown up. But in terms of the actual like content, yeah, that was I developed that with the team there and other stuff. So for me, like I'm really passionate about asking the right questions first before like kind of telling people what to do. And so I create these more as like a thought experiment for myself of like people keep asking me like, hey, how do we design our platform? Do we need this like super complicated thing? And I'm like, no, but why don't you need a super complicated thing? So that's the story of these guys.
Oh, that makes sense. Makes sense. I really like how it's like split into layers. I
Yeah.
really, yeah, I feel like that's just it helped a lot for me to understand as well. Very, very much so. Because I feel like ML ops is a space that's just kind of like everybody's going into and there's just a bunch of it's almost like a mixture of a bunch of different things. So understanding like where the layers are and how it actually works in detail is really helpful. It looks like the chat agrees as well. So, next question. There's quite a few questions right now talking about Elasticsearch and then also the roles of large language models and how all of that plays into things. So, yeah, what's the use case for Elasticsearch? Could it replace LLMs if you need like basic advanced search displays? And how does that play into the stack of the MLOps stack? While you're answering
Yeah.
that, I'm just gonna quickly go to the bathroom. Don't mind me.
Yeah. Okay. So let me figure out how to approach this. Okay. So, okay. Elasticsearch and LLMs. Okay. Um, Let me just start off with saying that first off, every single company right now is making an LLM play. And why are they? Because one, they want to survive. They want to make sure they're not losing out on a market, even if there isn't maybe like a very clear product market fit. They want to make sure they have like a foot there, right? Notice I'm not saying this specifically about Elasticsearch, just in general, right? Okay, so LLMs, what's going on there? Let's just ignore like all the OpenAI announcements because that's just easier. Um, okay, let's first talk about what are like some key snapshots of like the conversation. So I'll start off with this, right? So people are proposing like different stacks purely just for LMs. Now, what was the challenge of like prior LMs? So there's a couple things. So first off, a couple of challenges were one, LMs when they're trained, they're trained off of like a finite data set. So whatever knowledge they have like ends at that date. Now with GPT-3, it was and 4, it was 2021. More recently, OpenAI had announced that they had created a new set or like retrained it on 2023. So they added 2 years of data, right? But in general, if we kind of ignore the dates, LMs have a couple challenges. One is the knowledge is finite. Secondly, it's they hallucinate. And then the third challenge is really kind of like how do you how do you structure the output without retraining it, right? So where okay, so we've talked about that. So how do you deal with that? With hallucinations, it is very, very hard to actually control that. It's super hard. In terms of refreshing with existing data, or even data that it's not exposed to, like let's say, for example, you have internal company data. So there's this approach called RAG, Retrieval Augmented Generation, where essentially what you do is you create an embedding off of your prompt, right? You have an embedding off of the information within your database or whatever information that you want to like expose and inject into like the conversation. You then do a similarity search and you basically pull up the most relevant chunks. You then do some kind of summarization or you do some kind of formatting on the response and then you present it to the user. OpenAI announced like a ton of different sort of ways to cut down on a lot of those different aspects. So like custom functions, all that good stuff. So how do we connect it back to like something like Elasticsearch? So Elasticsearch is actually so Elasticsearch is part of like the ELK stack, right? Which also includes logging and a couple other things. So there's a couple different ways you can kind of see them relate to each other. One way is you can think of Elasticsearch similarly to how you would think of a vector database. Another way you could kind of think of Elasticsearch is like as a pure search. You could hypothetically use Elasticsearch with an LLM. You could use it to supplement data. You could use, I mean, that's actually that's the biggest thing, right? Is you can essentially use it to supplement data. You can also use Elasticsearch as well, like with a logging, with the logging component in the traditional way of you log stuff and then you search the logs. And then you monitor on top of it. So there's a couple different approaches to that. There's actually, I forgot her name, Susan. She's the DevRel over Elasticsearch. She's been doing a lot more stuff. I think that's her name, Susan or Susie. She's been doing a lot more talks and content on it. So I would highly recommend folks to go check her out. But that's like generally like what the pattern would look like. Now, something I do want to say is that like a lot of companies, they are trying to kind of figure out what does the LLM ops pattern look like. And there's a couple different kind of approach, like responses to it. So from enterprise companies, a lot of them are kind of looking at LLMs going like, okay, how can we make sure we don't get sued for like data privacy or breaches or even like injection attacks? How do we make sure we don't get sued? How do we make sure like using it doesn't break our existing products and systems and services? And how do we do it in such a way that we can cut costs and lay off more people? Sorry, that just came out. How can we cut costs? How can we cut costs? That's they're looking at that. How can we be more efficient, create new capabilities, right? That's what's going on there. Startups have it a little bit easier in the sense of like they don't have this huge like legacy like tech debt or platforms. So they're just trying to figure out like what's the minimum viable product we can build from it, and then what's like the minimum viable tooling we need to actually support those products. The mid-sized companies are in a little bit of an interesting place because a lot of them have some existing like data and ML tooling and initiatives set up. They might have some existing products. They have some of the headcount resources that they could be doing LLMs and like other kind of Gen AI stuff and incorporating to products. But at the same time, they don't have like the war chest that a lot of these enterprise companies do. So that's kind of like that's a very interesting spot to look at. What's the response to generative AI going to look like? And especially what's the MLOps response to generative AI is going to look like? Yeah, I know, sad but true. That's why it's good to build these skills, right? Like if you're a builder of this tooling, you're a little bit more future proof.
It really is that. I kind of feel like I've been doing a lot of these now. I know many of you guys have attended them. I feel like the trend that has come out really is the fact that if you're working in this field, like don't be afraid of these technologies. Because only by understanding these technologies and
Mm-hmm.
figuring out what you're doing with them are you the most exposed to different opportunities that are available. And I think, Mickey, would you agree with this statement? There actually are a lot of opportunities that are available in progressing the field if you understand how to use these tools. So,
Mm-hmm.
and it's also kind of like working in tech companies and things like that, there is a lot of opportunities, obviously, as everything is being built up. But understand that there's also a lot of things outside of tech, in which if you understand how to use these tools, you can dramatically make differences in different industries, like healthcare, for example, right? Like restaurants. There's just a lot of other opportunities out there that you can apply this skill set to.
Yeah, 100%. And I mean, this is like another good diagram from the Rise of the AI Engineer blog post where it was like, he was like, I mean, so that blog post was like Sean trying to make an argument that there's like a new role that's emerging. But, you can also look at this as a like, if you're on the SWE side or even if you're on the business side, if you look to the right of the API dividing line, like you kind of don't even need to go into like the data research, data science side. You can go straight to building products. You have like tools, you have the APIs. It just really becomes a question of like, can you kind of build like the front end MVP? And then can you kind of figure out the product market fit? It used to be you had to go like left to right. Now you can kind of just jump straight to the right. And then if you know you want to develop your own like in-house R&D, then you can kind of creep over to the left.
All right. Let's see, other questions that we have here. Can you please talk about experimentation? Oh, actually, we're at time. I totally didn't even realize we're at time. Uh, yeah, I guess we're at time right now. Is there any, if Mickey, you don't mind, just staying for like another 2 to 3 minutes to see if there's any like huge burning questions or things that people have to ask?
Yeah, sure.
And I'm also just gonna link Mickey's um, LinkedIn as well. So is that the best place to reach you?
Mm-hmm. Yep.
Please go, and I'm gonna put that in the pin as well. Please do go check out on LinkedIn. Nikki's profile, she talks a lot about MLOps, the way that it's adapting, and because she has experience in larger companies as well as smaller companies and startups, she's really great at kind of understanding from many different perspectives. She's also really involved in the MLOps community, so really good connections there as well. I'm just gonna, whoops, link that over here. Mm, Mickey. Okay, I'm gonna pin this. Okay, cool. So good talk. Thank you. Drop a like for the algorithm. Yes, please do. Thank you. Rise of the AI Engineer. I like that title. That's literally what I'm doing. Yeah, I think this is a very interesting piece. I feel we can go on forever about that. The the rise of the AI engineer, and I don't know what you would think about this, Mickey. The job of linking together a bunch of different APIs.
Yeah, I mean, I call that software development,
That's
but
true. But like
no, I mean,
LLMs
yeah.
APIs.
So, yeah, this is one of those things where it's like how, like I don't know how do I put this? Like, there's titles. Okay, so titles and like are really good for like fuzzy search match, where like I tell folks I'm an MLOps engineer because that's the area that I like working in. But do I constrain myself to that? Definitely not. Like, I also will take time to like upskill over in the data ops, data engineering side, taking stuff to like kind of time to like also build out some Gen AI apps and all that. So I think like the most important part is like making sure like people understand that like you don't have to like pick a lane. Like you should focus just because that's easier to develop skills in. It's easier to develop products. You're not kind of like, you know, being like tugged back and forth across like the entire landscape of tech. But I think like for example, if someone a lot of people because like I had a friend ask me this like when I was at Mailchimp, where they're like, I'm a QA engineer. Do I have what it takes to move over into MLOps? And to me, it was just the weirdest question in the world because this person had not only worked with they'd worked with like half the data science team on productionizing ML products. They'd worked with half the MLOps team and the data engineering team on building internal tooling. Like literally the thing that was like that they were hung up on was the fact that they didn't have it as a title. Like they weren't blessed with the MLOps title, right? Or they didn't have the right degree and all that. And they were like, well, I'm QA. It's like, well, you're awesome. You're like super awesome. That's what you are, right? Because they were doing all the same work, right? So I think that's also where people kind of need to like, um, they need to they need to buy into their own success, and they need to understand that like you know your job title or whatever, whether you're data engineer, data analyst, data science, whatever, right? Just build the skill sets, just build up the projects, and then you know make sure you communicate it, but don't get too hung up on like what you know other people kind of think you are. That's the beautiful part about tech. It's like it just comes down to like what can you actually build. If you can build it, great. Then that's who you are. If you can't build it, then you can go learn. So
Good way of putting it. All right. Love the session. Thank you both. Thank you, Tina and Mickey. Thank you. Thank you for taking the time breaking it all down for us. Yes. Thank you again, Mickey. You are amazing. And to answer the question, should you be a generalist or specialist? Can I hazard to say, Mickey, you would like to go towards the generalist part in which you want to expand on things in the whole field?
yeah, I mean the way I look at it is like at the end of the day, like if I think it, I want to build it. Right. That's where I want to go personally. Like but also I think in general that's where we should all kind of think about aligning our own individual efforts and career development is if you want to go do it, then what will it take to get there? So
And with those words, thank you everybody for joining. And I'll see you guys next week. All right. Have a good day, everybody. Bye bye. And we are done. Thank